Good morning, everybody. We're going to talk today about some things that most of you are already very aware of. My purpose in this video is really just to kind of catch everybody up. Some of you are going to say, man, I learned this stuff back in 3rd grade, 6th grade, 8th grade, 9th grade, whatever it is. And others of you might have heard it before, but maybe you don't remember it. Maybe there's even some of you who haven't heard any of this. So I want to just right now, we're going to do a brief video of just trying to catch everybody up and we can all agree and be on the same page. So the question for today is this idea of area and perimeter. And I'd love it if I was there, I would ask you, and I'd love to hear how many people could tell me what's the best way that they could describe area. I asked a class yesterday and they wanted to talk to me about mathematical formulas. Well, it's this times this, and perimeter is this plus this plus this. But that's not what I'm talking about. I'm talking about if you were dealing with a kid from the elementary school who had no concept of what the word area or the word perimeter meant, how would you best explain it? And different people had different ideas, and like I said, a lot of them kept coming back to the mathematical formulas of it, but that's not what we were trying to do. And so I was impressed that someone eventually looked at my room and they noticed around the base where there'd normally be maybe a baseboard, there is a dark gray piece of plastic trim that runs all the way around the room. And that trim actually comes in a big roll. And so you have to cut off a length, and that length has to be the right length to make it all the way around the room. And that's a great way of describing perimeter. Perimeter is this length that goes all the way around the room. Now, a lot of times then when you think area, you go, okay, well, I'm looking at this trim board or this piece of trim for perimeter, so area, I must look at the carpet. But that's where someone spoke up yesterday and did a great job. I said, if I was trying to explain area, I would tell them to look up. Because when you look up, you see all the square tiles of the ceiling. And that's how area is measured. Area is measured in square units, whether it be square inches, square feet, square miles. And so what a great way of describing area, of saying, look at how many tiles it takes. Look how many of these square tiles it takes to cover the openness of this room. And again, so those were great ways. When we think about perimeter, we need to think about a length. We need to think about area. We think about how many squares does it take to fill a specific region. All right, and so those are our basics. Now, what we're going to do is we're going to talk about those concepts, area and perimeter. And first, we're going to start talking about them in regards to a rectangle. And this, if any of you know any of this, this is the stuff you're going to know. Area of a rectangle is easy. The area is, now you might have a different description of it compared to how I say it, but I'm always writing on a vertical board or a vertical screen. And so I say area is base times height. Now, you might say length times width, and I'm okay if you say length times width, but I will always say base times height because I look and go, here's the base, here's the height, because again, I'm usually dealing with a vertical surface, okay? And then perimeter is that length all the way around. And so to find the perimeter is two lengths, or two bases plus two heights, okay? And that would be the perimeter. All right, so with that in mind, I've got this rectangle here below. It's got one side that's 7 and one side that's 13. I don't think it's going to take you long, but I would love everybody to find the area and the perimeter of that rectangle, okay? Find the area and the perimeter of that rectangle right there. So we can pause the video right here and then we'll go over it in just a second. Okay, this is obviously really simple. Area, so the area of this thing is equal to base times height. The base of that thing is 13. The height of that thing is 7. So 13 times 7 is 91. That is the area. And then if I wanted to find the perimeter, I'm gonna move this. If I wanted to find the perimeter, I know that the perimeter is equal to 2 of the bases plus 2 of the heights, or length and width. If you want to use those, that's fine. And so therefore you get 2 of the bases, that's 2 times 13, plus 2 of the heights, and that's 2 times 7. 2 times 13 is 26. 2 times 7 is 14. And that gives me a grand total of 40. Now, when I do these, if I said 91 what, you should say 91 square units. If I had put inches or centimeters or something like that, you could say 91 square inches, 91 square centimeters, 91 square miles. But when it comes to perimeter, it would just be the length. So it's 40 inches, 40 miles, no square. And if you ever see it written where it does have something like, let's say this one I had put inches and it says 91 inches squared, you might see this little exponent right there. Okay, this does not mean to square this. This is referring to this unit. You know, to say inches squared is the same thing as saying square inches. It's literally the same thing. So inches squared, square inches, same thing. All right, so there you go. Area and perimeter rectangle are easy. I'm guessing you already knew how to do those. Okay, so let's step it up to a triangle. All right, if we're looking at the area and perimeter of a triangle, well, the easiest thing for us to do is to draw another rectangle and then divide it down the middle as I've done here and go, okay, that would mean we have one triangle up here and another triangle down here. Now this triangle still has some given height and we can give it the same height of 13. It's got some given base. We'll say it's got a base of, the height of 7 and the base of 13. And so then we know that the area of the whole thing would be 7 times 13. So therefore the area of a triangle is 1/2 of base times height. Okay? And so literally the formula is area equals 1/2 base times height. But now we need to hit a quick little math lesson. Make sure you never distribute in multiplication. You can distribute in addition, but never distribute in multiplication. If I have 1/2 of 4 plus 6, I learned a long time ago that I could distribute that 1/2 to each of those, and you could say half of 4 is 2, half of 6 is 3, 2 plus 3 is 5. Now let's try that differently. If I said 1/2 of 4 plus 6, and I add the inside first, well, 4 plus 6 is 10. And half of 10 is 5. Hey, check it out. Math is true. Okay? The distributive property works, but it only works with addition and subtraction. It does not work with multiplication. You cannot distribute multiplication. So if I say 1/2 of 4 times 8, and I want to make that and say, well, that means I could distribute that 1/2. You can't do that. But let's say I thought I could do this and this. I would go half of 4 is 2, and half of 8 is 4. 2 times 4 is 8. And let's try that differently. 1/2, 4 times 8 is 32. 4 times 8. So you go 1/2 of 32. Half of 32 is 16. 8 and 16, not the same numbers. You can't distribute in multiplication. So, what's an easy way to do this one? Well, a lot of times, if one of the numbers is even, I just go ahead and take half of that one. And it just makes it a little bit easier. In this case, I'm dealing with two odd numbers. And so I'd say, well, area is equal to 1/2 base 13 times height, 7. And I can multiply 13 times 7 and then cut it in half. I can take half of 13 and multiply that number by 7. It doesn't matter. Multiplication is commutative. You can multiply in any order. But bottom line is I get 40.5. Now I know in that picture, it's very clear that that triangle is exactly half that rectangle. But that formula, this one right here, actually stands for every triangle. If you know the base and the height of the triangle, then you're good. Now the only time where this starts to get a little bit tricky is when people don't realize, but let me move that out of the way. They don't realize, but you could have a triangle that's like leaning like this. And they might say that this right here is 4 and this is 10, and then there you could go, hey, and if we actually continued this right here is 5. And if someone said, well, what's the area of that rectangle? Well, the 10 actually has nothing to do with it. 4 is the base of that triangle, and 5 is the height of that triangle. And so 10 is just one of the side lengths. I could also tell you that this side length is 6. It doesn't matter. Okay, well, it actually can't be 6 because 6 plus 4 is 10, so that would make it too long. So we'll make this one 7. But so it doesn't matter. The 10 and the 7 can be completely ignored. If I wanted to find the area, I would say 1/2 base times height. Half of 4 is 10. I'm sorry, half of 4 is 2, and 2 times 5 is 10. So I would go, that is 10. Okay? So you would ignore this one and ignore this one because you only care about base and height. All right, now let's have the last little bit of fun. If you've heard of the area of rectangles and you've heard of the area of triangles, well, let's finish triangles, I guess. First, we got to talk about the perimeter of triangles. There is no formula for the perimeter of triangles. The perimeter of triangles is just all the sides added up, okay? There is no formula for that. All sides added up. There's no nice little sweet clean formula. We don't have it because every triangle could look different. So you just take the 3 sides and add them up, and that's how you find perimeter. But what I was starting to say is the one thing that I think a lot of you probably have not done is to find the area of a parallelogram. So that's what I want to do here. Like, let's look at this parallelogram, okay? When I look at this one, I had a student yesterday I was really impressed by who said, well, I think I could find the area of that. I said, okay, great. Because people see the 3 different numbers. I've got 10, 8, and 15. 15 is clearly the base, 8 is the height, and 10 is that side length. And so the question is, well, which numbers do I need to multiply? And the student I was talking to noticed that if you took this part right here and maybe shoved it over here, like you cut it off where that dotted line is and shoved it over here, what you would have is that would fill this section, okay? And it would make it kind of look like that, which now, as you look at that, hopefully you see all I did was create a rectangle. And we know how to find the area of a rectangle. The area of a rectangle is base times height, okay? So the area of a parallelogram is base times height. Again, we've got this other number here, in this case, this 10, that just doesn't matter. We don't care about that 10. It has nothing to do with this, okay? So we go base times height. So the area of a parallelogram is base times height. It's still just base times height. So in this case, I say the area is equal to base, which is 15, times height, which is 8. So the area is equal to 15 times 8 is 120. Perfect. All right. But there's only one thing. What if I change some things just a little bit? I'm going to slide this in here. Okay? What if I said I want to know the distance right there? The distance from that side to that side. How far apart are they? And notice I drew it so it's perpendicular. All right? And I've had some students, I'm sorry, that's not true. I've had very few students actually be able to figure this one out. But here's the deal. Some of you might be able to. If you take this parallelogram and turn it, you could turn it this way so that now x is the height and 10 is the base. Now it's the same parallelogram, so it has the same area. So therefore, I can figure out what x is because I know the area of a parallelogram is base times height, and this still has the same area. But now it's got a base of 10 and a height of x. So I would say it's 120 is equal to 10x. And if you divide both sides by 10, you get x is equal to 12. Okay, that might have been pushing the limits of a little bit of a challenge this morning, but I think you guys can do it. So here's what we're going to do. I'm going to give you an opportunity to do some practice problems right now, and then I will cover the answers of them in just a little bit, okay? So go ahead and get ready. If all of the practice problems, I promise, are really simple. You're not going to have a problem.